Don't know how an ERC-20 token works? Stay solid, because in this video we're diving into the ERC-20 implementation. Hello and welcome to the DecentraWise channel. I'm Miguel, and in this channel we share information about Web3 and blockchain development. So if you haven't done so, please smash that like button and subscribe to follow our videos. So the first thing we need to do is to create a project directory. Make dir project, why not? And here again npm install save dev hard hat as usual. This will take a second. And then we need to initialize the hard hat project. So npx hard hat init. We're going to choose TypeScript and all the defaults. And there we go. Now we start VS Code. And the first thing we'll do is to delete the default contract that is created with the init function. Delete, and let's create another one. My ERC-20 token.sol will update later. Okay, let's start by creating the contract. Contract my ERC-20 token. And now we can go to the Ethereum website, to the ethereum.org website, and they have the methods here. So we just copy the methods and put them here. Let's set up the functions properly, and another one. Okay, we're all set. Now we can start developing the contract. Oh, we still need a constructor. Okay, so let's start doing this. First thing, we need a string with the name, memory name. How are they doing? It's before. Okay, underscore name and string memory underscore symbol. So these are the two first properties that we need. So we need to also create them here. Memory string private. Now name like this, and string private symbol. Okay, there we go. Now name equals name, funny underscore stuff, and symbol. No, not like that. Okay, so now we are able to just return the name and return the symbol. Okay, so we are done with this too. Memory requires this on the return. Memory, so it's a string memory. The other two things are the decimals and the total supply. So we are also going to add them here in the constructor. Int total supply, and with an underscore before, and int 8 with the decimals. Right. The same, we are going to create the properties. Int 256 with the total supply, and the uint 8 with the decimals, and set them here. Total supply equals total supply, and decimals equals to underscore decimals. Okay, so we're all set up. We can now return those properties here. Return decimals and return total supply. Okay, so this is the basic stuff. Now the balances will be managed by a mapping. The mapping will be addressing each address of each wallet, and will give us the amount. So we are going to create a new mapping. Oh, nice. 256. We will call it balances. And if we are getting the balance of somebody, of some wallet, we just return the balances of the owner. Nice. Now, if we want to transfer some tokens from one account to another, we have to subtract from one address that specific value from one address and add it to the other address. So what we are going to do here is the balances to, we are going to add that value, but now we need also to remove the value from where we are taking that value from. So balances owner minus equals the value. I don't know how to type. Okay, so now we don't know who the owner is, but we know that the owner will be the one making the transfer. So address owner equals message sender. So what this is doing is type owner properly first. So what this is doing is getting the owner from the one that it's sending the message, and by sending the message is the address that it's calling this transfer function. And we also need to return something. Return true. Now there are two ways of implementing this function. One of them is, let's say that we were going to check the value before making the transfer, and we could do things in two ways. Checking with an if the balance of the owner is inferior to the value, it would have to fail, right? So we would return false. Another way to do this is remove this and make require, and we are going to require that the balance is bigger or equal to the value. Otherwise it will fail and it will return not enough money. Okay, so we have these two ways. Problem is, when you are dealing with an ERC-20 token, you don't know which way it's implemented, or you don't need to know. So it's a good practice to check if the transfer is true, it returns true. Some of them will implement with the require, which will revert the transaction, but there are other tokens that will fail by returning false. Right now we are not going to bother with any checks. We are just hoping that everything goes all right. We are just making this as simple as possible. Okay, so next one will be, okay, before implementing this transfer from, we are going to implement this approve and allowance. How this works, and these three functions serve a purpose. They are authorizing a third party to make a transfer on our behalf. So a user will allow somebody else to make a transfer on his behalf. So what we are going to need right now is an allowances mapping, and this allowances mapping, let's create a mapping, and we need a mapping of a mapping, which is weird at first sight, but it will make sense. I will explain it. And we are going to call it allowances. And now when we are going, okay, so if a wallet is going to allow a spender to spend some money on his behalf, we will have to say that the owner is allowing the spender to transfer this value, or until this value. It doesn't know who the owner is, so we will need to create the owner. The owner will be the message sender. So it's the one that it's calling the approve function, that it's allowing the spender to spend some money on his behalf. As you can see here, also it's complaining that we need to return. So we return true because we always succeed in our functions, and we will always return true, at least for now. If we want to check the allowance, we will return allowances from the owner to the spender, and this is it. It's done. Now all we need to do is the transfer. If we are going to transfer something, make it so like this, but now it's called from. Nice, seems to be working. Okay, and we need to reduce the amount allowed on the amount of value. This is 2, this is from. I think this is correct. Yeah, I think so. Return true again, because we always make perfect functions and they always succeed. So this is it. We have a very basic implementation, and let's try to test it. But first we need to do a deploy script. So this is the one that is created by default by hardhat init. We are going to delete everything. We don't need any of this. So what we need is an async main function. Oops. Function main, and what we are going to do here is to have a factory. Factory equals to await ethers dot get contract factory, and then const token to await factory dot deploy deploy, and here we are going to pass the parameters. So let's try the first one. My first token, my ERC token, and let's call it ERC-20. My first, not first, but ERC-20 token. And now let me remember, it was the total supply 1 million plus 2 zeros for the decimals, so we have 2 decimals. And now we can do a console log, not love, it's log. By the way, please click that like button, smash it strongly so that I can grow our channel. It's very useful for us. And subscribe so that you can get notifications for more videos. And here we can log something like token contract deployed in address, and we can get the address. Await contract dot get address. Yeah, come on. Not like that. It's await contract dot. What are you doing? It's not contract, it's token. Get address. So this is it, I think. Let's see. So npx hardhat run script deploy. We are missing this. Yeah, we are missing the Solidity version in our contract, and something else. What? Oh, yeah, the license. And we can have it as an MIT. So let's see if it works. Still not working. What's wrong? We didn't save the file. Come on. Let's try again. Wow. Yep. That doesn't work. Oh, of course, we need to set my ERC-20 token. This is it. Yeah. So the token is deployed in this address. So we are successful on this. Let's go for the tests. So let's delete these tests and create new ones. My ERC-20 token.ts for the tests. And what do we need? We need to import hard hat, and now we have the describe my ERC-20 token and an async function, and it deploy. Oh, you don't know how to type deploy? Come on. Again, a sync function, and we are going to need the same as in the deploy script, so I'm just copying it, and now we can verify if stuff is being done properly. So we expect, it's not expect, of course it is expect, I'm missing something here. Import shy, is it from shy, right? Expect from chai. Okay, so we should have expect working. Now expect token dot name to be, we need to set it up, right? My token name, so this will be the name. Wait, of course doesn't know about the name. Really? Why not? Of course not. My ERC-20 token. Now you do know, after all. Okay, let's create a symbol. My ERC token. Let's make some other expects for the symbol. My ERC token for the decimals. We only pick 2 decimals, and total supply, which we have 1,000,000 tokens, plus 2 zeros for the why are you come on, of course not. To be equal they could have done this easier. Nope. What are you complaining now? Right, why? To be equal, come on, and to be equal again to 1,000,000 plus 2 zeros. We're missing a parenthesis. Yes, we are missing, but we have 1 extra here. Okay, I think this is it. Now to run this, we need to run npx hard hat test. Let's see how it goes. Nice. Let's see the errors. So if we put a name with some other things, not this, let's run again the tests, and there we go. We have a failure because we were expecting the name to be with the 3 A's at the end, and it's not, of course. So if we remove 1 0 from here, we will have a different value on the total supply, and it will fail again. Yeah, so there we go. Tests are working fine. Okay, let's roll back the 0. We can save and run the tests again, and everything is passing. So we can wrap up this video. On the next one, we will try to optimize and create some security for the token. We need to make a lot of checks here not to allow to make bad transactions here. So on the next video, we will dive into the security and optimization of our ERC-20 token. So see you on the next one.